Hello everyone, and welcome to my talk about 10 years with Neovim. So Neovim was announced in early 2014, which is almost 10 years ago by now. So it could make sense to go back and see why was Neovim started as a project, and how has our goals and overall design decisions evolved over this time. And there's just a lot of things going on in 10 years, so it could be fun to go back and look at them. So, I've been a regular contributor to Neovim since almost the start, and since then I am a core maintainer with focus on things how text is rendered on screen, and in particular features for both GUIs and the terminal, things like adding virtual text and decorations on top of the text. And let's just jump straight into it. So back in 2013, before all of this, the Vim ecosystem for plugins were thriving, and there was an interest in particular for this sort of plugins which would make a good use of asynchronous event handling. And what is async event handling? At the most basic level, it just means at the same time as the UI is waiting and prepared to handle input from the user, Vim can also handle various other external events. Like, for instance, if you do real-time collaboration, it will need to handle data from some internet connection. And basically everything we think of today as LSP, things like compiling and linting your code in the background as you type and giving you back immediate feedback. So naturally there was a lot of talk about this on the Vim mailing list, and even patches like better support for multiple timers, and also patches by Taruda, who later went on to start Neovim. So in particular, this patch for adding non-blocking job control to Vim script, which means that you can start external processes which could work in the background and you could communicate with them. And all of this was met with quite some interest, but also some resistance, because the maintenance burden of the existing code in this area was already quite high, and now you will pile even more stuff on top of it. So this was not what happened. So Thiago de Arruda realized we need to take a step back and talk about the maintenance of the entire codebase. So he announced the fork of Vim called the Neovim, together with a fundraiser on Bounty Source. And you cannot find this original announcement post on the webpage because Bounty Source has gone through some changes as a company. But you can still find it on Web Archive using this link. You just cannot see it. It just says loading, and but you can go in and inspect the source code and remove this display non-CSS attribute, like big time hacker stuff. And then you see the actual text. So anyway, so he realized that we need to work more with improving the quality of the underlying code base, and let's focus on the solution part, as that is what we can compare to what's actually been done later. So we will remove a lot of things like support for really old platforms, and get rid of compile time features to simplify the code base. And the main point was that in this new model, plugins will be written as separate processes which will communicate with Vim using some RPC protocol, which sounds familiar to this patch he wrote before. And but also UIs will be externalized and communicate using the same RPC protocol. So we can remove a great deal of code dedicated to handling terminals, which is deeply entangled with the underlying implementation of the screen. And we will use the same interface also for testing, and also using external libraries, in particular libuv, to get rid of a lot of platform support and handle async I/O across multiple different platforms. And as this turned out to be very popular, but also controversial, but in a good way, so there was also a lot of support. So he also were able to add some stretch goals to the plan, and one of them was re-implement Vim script as a language that compiles to Lua, which is really ambitious. And then also refactor the editor as a library, so you can also embed it as a C library in some program and access it without the RPC protocol. So let's talk about the work which was done. So I think the really most important refactor, and this was even something which was done in the first commit of the new repository on GitHub, was to delete most of the compile time features, by which I mean that this is not only about things like if you compile Vim with GTK support or not, or for different platforms. These are like internal features of the editor itself, and this is some code for rendering text on the screen, and already the logic for runtime, which is the if statement on the right, is like complex enough, and then you also need to, all of this code has to be valid even for all the combinations of these if-defs being turned on and off and compile time. And I don't really know. It's like this is already complex enough just with everything included. And I think this was a prerequisite for many other refactors that then followed. So some other changes were just on the general theme of cleaning up the code base and modernizing it. Like, instead of using int and long and short, which are platform-dependent types, how big they are, often it depends on the use case how big integers we need. So if it's enough with 32-bit or 64-bit. And also massive cleanup of the different character types, which has been a really long-running project, which has was really finished later this year even. So this has been a lot of work. And also invest in tooling, like we run all the C code in the test suite with sanitizers to catch runtime errors. And also we take the help of static analysis to help find issues with the C code. So let's dive into some specific example to maybe make it more concrete. So as I mentioned, something that I've been working on is how text is represented on the screen after you have rendered it. So in the most basic setting, the screen is just like a terminal. So it's a matrix of cells, and each cells contain some character and also a attribute, which is often the color. And but things get complicated depending on the encoding of the text. But at least in Neovim, to support multibytes encodings is no longer a compile time feature, but in some sense it's also a runtime feature originally, because you can choose what is the internal encoding of the text, and you can also change the encoding after startup, which doesn't really make any sense. So I had this idea we should only allow UTF-8 as the internal encoding, because you can still convert it across boundaries, and UTF-8 can represent everything that's really in a file, even if it's another encoding in the file. And this was quite interesting, and but some of the maintainers, especially Justin, said like, "Whoa, this is kind of interesting, but maybe we should take these more stepwise." So first we said we should always default to UTF-8 as the internal encoding and not allow to change it after startup. And it turns out, surprisingly, that people were very happy with this, that people want to use Unicode. So we could move on with this plan and finally only allow UTF-8 also as the internal encoding, which led to further simplifications. Like, if we see how text is stored on the screen, it's both a smaller grid only for the ASCII part, and then there is sort of like overflow buffers if there is a actual Unicode character in the cell, and also if there are multiple composing characters. because in Unicode you can have multiple code points which gets combined to a single visible character. And I thought that why don't we just represent the character which is in each shell as just the UTF string, which will need to be sent to an external UI anyway to render it. And this was great, but it has some issues, like now things are not so compact in memory anymore because the largest possible such combined character is really large, so it doesn't help with the cache locality. So we changed it back to make it a bit more complicated, but also more forward. So now we say that only UTF strings up to 4 bytes are stored inline in the grid of the screen, and then we can use an escape byte, which is invalid UTF-8, and instead interpret it as an index into a table of pre-composed characters. And this then only needs to get dynamically allocated if you actually use these huge combined characters. And but all of this really goes back to this original idea that all features should be enabled at compile time. So even more multi-byte features like shaping of Arabic text and right-left rendering as such text, as it could be greatly simplified the implementation just because it was always available and we didn't need to consider both cases of all these if-defs. And all of this is quite connected also to the external UI protocol that UIs need to consume. But I talked quite a bit about that part in last year's Neovimconf talk, so if you're more interested about that, I suggest you watch that one again after this. And something which has been quite important in this area and many other areas is to spend a lot of effort into testing. So I like to call our overall approach in general regression test-driven development. So we have different kinds of test suites. So with unit tests, we mean that you can call an internal C function using Lua FFI as we are writing the tests in Lua. But the most important category of tests, I think, is really functional tests or behavioral testing. Because this testing framework, it's reusing the same RPC framework as remote plugins and also UIs are using to communicate with Neovim, which means that the test can simulate behaving as a UI and sending user input. And then there could also be RPC calls from some other source. And then Neovim will send the exact state of the screen back to the test runner. And we have this function snapshot, which then renders the state of the screen to standard output. And of course it renders it as Lua code, because then you can just paste that Lua code back into the test case. And now the next time you run this, it will then assert that the state of the screen looks exactly the same as before. And now we have over 4,000 expected screen states of this form. And I would say this sort of big scale refactors would be impossible to do with any confidence without this extensive testing, which really tests to the last single character on the screen that it still looks as we intended it to. So let's switch to some other topics. So something we have done quite a bit is student collaborations. So quite early in 2016, this headline feature called incremental substitution, which is that when you type an X command for finding and some text with a regex and then replacing it with some pattern which depends on the regex, it will give you interactive feedback. And this was originally prototyped as a month-long project of a group of students in a programming course. And they managed to produce a working prototype in collaboration with us in a month's time. And then, of course, it took a bit longer time, and we in the core maintainers had to go through the code and change it a bit so it's more in line with what we had in mind. But in the end, it was merged later the same year, and it was a huge success. So we wanted more of this sort of thing. So we applied to the Google Summer of Code program. And this is a program run by Google where they will put students together over a 3-month period in the summer together with an open source project, and they will give some funding both to the students and also to the maintainers of the project. And we had some high impact code being produced as part of this program. So for instance, finally making the terminal UI into a separate process as was originally intended, and a lot of interesting features. And I would say in general this was a good experience. It's like really drove our processes for onboarding new contributors into the code base. And also in the end, high quality work was produced and merged, which is very important. But on the other hand, something we noticed, it's harder to keep this kind of student contributors around afterwards, because typically what happens is that as they do this over the summer and immediately when the program is finished, they need to get back into college and do full-time coursework, and then they sort of lose the connection with the code base and the work. Not every student, but this is quite common. So we haven't gone back to this for other reason, because it's also a big time investment. But I think this is something we could look into again in the future in some form or another. So let's talk about some important design decisions, like the language question. So in this originally plan, as it was formulated, Vim script will still be the main configuration language which runs inside the Neovim process. And this sort of stretch goal was to make the Vim script faster by compiling it into Lua and running it inside LuaJIT. But this quickly encountered some hurdles, because classic Vim script is not really possible to compile. It's not really even possible to parse it. A simple thing just like if you echo x.y, so what this dot operator means, or even how this y identifier gets interpreted, it depends on the types, runtime types of the variables. So this could either be a string concatenation, or in other case, this very same line of code couldn't be interpreted as a field access. And this is just an example. So unfortunately, this didn't really lead to anywhere. But and then in parallel, we also supported asynchronous plugins with remote hosts, so you could write the plugins in any language using our RPC protocol. And something that people will often reach open issues on GitHub and say, like, why do you use Lua? Why don't you use JavaScript as the primary language? Because it's more popular and it's a bigger ecosystem. But we'd like that LuaJIT is still quite small for its performance and usefulness, and it's designed to be embeddable. And there's really no standard library, but Neovim is the standard library. It's the point is that plugins and configurations access the functionality that we provide. So there wasn't really like any big board meeting where we are saying like, oh, we're going to go all in Lua. It was more like we added this high impact PRs, and given that this compiled Vim script didn't turn out, it really made sense that we just exposed Lua itself as the primary language for configuration. And so Vim actually sort of agreed with this conclusion that it's better to have one focus language rather than investing in multiple different embeddings. But they took a different path, because they instead went on and made a major revision to Vim script. It's like a separate language called Vim script. And history doesn't repeat, but it sort of rhymes, because now, as Vim has been rewriting some of its runtime files, which we still like to port and include in Vim script, it makes sense to compile this Vim script code, which is actually possible to parse, into Lua. So it's just interesting to see how the circle gets completed in a sense. And to really drive this point home, so we used Lua since early the beginning, mostly as an infrastructure language for things like testing and also as a better preprocessor for the C code. So we can do code generation to avoid a lot of boilerplate. And but then over time we added it as a feature into core, and I think some high profile events was the implementation of the built-in LSP client, which was written in Lua using on top of the libuv bindings to Lua. And also treesitter was to the beginning it was exposed as Lua bindings as to the runtime treesitter library. And this has the effect, by written in Lua, all of this is immediately accessible to plugins and configurations, which also is written in Lua. But of course, then there is this concern that we still need to delineate what is a public Lua API that we promise any kind of backwards compatibility, or what was really intended as internal code. Yeah? Because this is something we have seen in the recent versions, that they are like breaking changes, but this was really intended to be an internal part, I think. And then we went on and really invested into Lua as first-class configuration with access to all the important interfaces to the editor itself, like key bindings and auto commands. And then even add type information to all of this, so you get help when you are editing your config using a Lua language server. So let's move on. The language question, but this time about the internal language of the core editor itself. Because Neovim is still written in C, like Vim, even though we have switched to a more modern style of C. But very early, there were a discussion like, now that you only support modern C compilers, which really also are C++ compilers, why can't you just allow us to write C++ code in pull requests and add that to core? The sense at the time was like, we have a problem. We are dealing with really messy C code, and now we are going to add C++ into the mix, and now we have like 1,000 problems. So it didn't really feel like an improvement in the big scale of things. But of course, time goes on, and also the open source ecosystem as a whole moved on, and the meme then later became, why don't you rewrite Neovim in Rust? And I think the answer to that is, it really depends on what do you mean with rewriting it into Rust. So one idea is that you sort of gradually rewrite the codebase in Rust as you refactor individual modules. But then you have these problems like only unsafe code can really access and call into C code and access any C struct which has pointers to other C structs and so on, because all of that is considered unsafe by Rust. So in the ideal sort of case, you will have a C part of the code base, and then you will have some unsafe Rust which acts as a binding wrapper layer around this, and then you can write new stuff in safe Rust. But the problem here is, if we're gonna let this loose and rewrite different parts in Rust, the problem is that all over the place we are accessing the same core data structures which are all in C. So it's really hard to define clean abstraction boundaries to avoid this situation where it's just all over the safe. I'm not saying it's impossible, but it seems tricky. But something which I think is more realistic in a shorter run is that we allow us to use libraries written in Rust, which then exposes a clean, simple API which can be easily wrapped in C. And it makes sense to mention treesitter here, even though the component which we actually embed into the source code, the libtreesitter, it's still all C. But the treesitter combining tool, which is a compiler which compiles grammar definitions into the parser code in C, all of that is written in Rust. And some distributions consider that our compilation process then really depends on Rust already, because you need to run this Rust code to verify the entire chain of trust from the actual source code. So in some sense, we have already crossed the Rubicon here. And so this is something which might happen. And but sometimes I get the sense when people say, you should rewrite it in Rust, that you should start over from the beginning. And then I like this motto by the Handmade community, which is, don't just rewrite, reinvent. Because if you're going to start over from scratch, then what you should do, you should reconsider everything. Like decisions of what is going to be part of the core editor and what things will be delegated to plugins. And you can move on and say that, why don't we adjust the primary key map to be more efficient with modern ideas like multiple selections? And then you get helix. So I like to say, sometimes as a joke, but also quite seriously, like, why don't you rewrite Neovim in Rust? It's like, that already exists. Like, this is how it will look like. And but of course, there's also other options, like I talk a lot about SIG because I use SIG for other side projects, even though SIG still has quite a bit until a stable release, and I think that's a criteria for considering it seriously. But it's more geared, I think, to handle this sort of situation where you deeply connect it with existing C code. So the motto is maintain it with SIG. So you start with just working as a better build system for all the existing C code, and then it does things like importing C headers and also exposing headers from SIG code. But then, given that we have decided to stick with C for so long, it means that we have invested in a lot of tooling to better deal with all of the C code to make it less worse, at least. So we can talk about related to this, like existing libraries, which we already use in Neovim. To reduce the maintenance burden, we can reuse libraries for things like libuv, which handles a lot of platform support and supporting async I/O across multiple platforms. And here is a timeline, and what this means that when it's gray, it's a dependency only for build time. But what we have seen over time is that the things that we include very early for use for building, we then realize we should expose it also for runtime. So a thing like this Lua parser expression grammar, which we use in the code generator, now it is also included in the runtime, and it's used to parse snippets from LSP. So the lesson learned here is like, just don't hide away the useful dependencies of the build system. We should also expose them to plugins. So I don't really have time to go over all of this in detail, but it's just interesting to see all the features we've been working on over the years. And I think there has been a shift of focus to do more maturation, like doing quality improvements to the tree-sitter and LSP support we added in 0.5. There's also been changes, like we shifted from just having one single branch, so we have separate branches for releases, so we can do patch releases and bring out bug fixes quicker to end users while still doing more risky work on the master branch in parallel. So after all this time, it could make sense to compare with the original goals and see, did we stick with the plan, or did we go into a completely different direction? And I would say that a lot of things in this original announcement, it's also what we actually did. Like, some things was quite obvious, like the need to clean up and simplify the code base. And also UIs were fully externalized as RPC processes, even though Taruda's original plan was to maintain the terminal and also a more modern graphical interface in Lua as part of the organization. But instead we have the terminal interface as a separate process, but it's written in C using these useful libraries. and the graphical interfaces are instead third-party projects. And also plugins that the plan here was to make VimScript faster, but we sort of pivoted to instead use Lua as the first-class language. So still we produce a lot of the original intent, but we shifted how it will be implemented. And also, you can say that LSP servers, in some sense, they are co-process plugins, but they use instead the RPC protocol, which is defined by VS Code rather than us. And finally, so the last stretch goal was to refactor Neovim into a library, and on paper this checkbox has been crossed because you can build lvim libnvim.a and include it into a C project, but there is really no stable API, so there's no like delimitation between what are the public headers and what are the internal headers. So any internal change will be a breaking change, and I think defining this stable API is a precondition to really say that we have Neovim usable as a library. But it's thing that's been going on, and yeah. So overall, I think we had worked very well on the original plan and made adjustments as needed. So thank you all for listening, and see you.